Alright, for this particular demonstration we'll be testing a automotive crankshaft, and we've simulated a free boundary condition by supporting the crankshaft from soft bungee cords. And in order to facilitate alignment between the test article and the shaker, it's a good idea to use a bubble level, and it looks like our crankshaft is hanging level, and we want to be sure that the shaker body is also level with the test article, and it looks like we have a pretty good level. So that means that when we excite the test article, we're more likely to get the orthogonal directions that we're interested in. It will be exciting along predetermined axis, as opposed to having the shaker canted at some angle and the crankshaft at a different angle. So we'll get everything leveled up. That looks good. Looks good. We want to excite the structure in both the vertical axis and horizontal axis simultaneously, so we'll use a skewed input, and we'll adjust the shaker body in the trunnion such that we'll be exciting at about a 45-degree angle, so that we can get both a horizontal and a vertical input. For this particular test, we're going to be using a 208 general purpose load cell to measure the force. And we need to attach a mounting base to the test article, and for this demonstration we'll be using a 2-part epoxy. And we'll give that epoxy some time to set up, and we'll continue in a moment. Okay, now we have attached the mounting base to the test article, and we've allowed some time for the epoxy to set, and we're ready to mount the load cell. And this is a standard 208 CO2. And the load cell threads onto the mounting base with the 1032 stud. And I'm just going to, for the demonstration purposes, make it hand tight, but you may want to use a couple of wrenches to tighten that up. And we have to be particularly careful about shaker alignment. We want the shaker and stinger to be perfectly aligned with the load cell for several reasons. One reason is we want to minimize the cross forces which are being applied to the object. If the shaker is not aligned with the load cell, we'll be putting in a force normal to or along the line of the stinger, but we also may be imparting some side forces or moments to the structure which won't be measured by the load cell, and that would be add errors to the test. So for that reason we want to get perfect alignment. For another reason, we want to protect the armature of the shaker. If we have significant side force or moment on the stinger, we may actually damage the support structure inside of the shaker as well. So for those reasons, we want to maintain nearly perfect alignment between the stinger and the load cell.
You should explain how easy it is to do that.
It's rather easy just to eyeball it. Go ahead and visually align. And I'm doing that in two axes. I'm looking at the alignment along that angle, as well as alignment along this angle. Once you're satisfied with the alignment of the stinger to the load cell, a last alignment check is actually threading the stinger into the base of the load cell. And if alignment is adequate, the stinger should thread into the load cell very easily. If it does not, that means there's some side load or something that's not quite right. But in this case, the stinger threads very easily into the load cell, which means we have good alignment. So you want to tighten the threaded portion of the stinger into the load cell until it bottoms out, and then back it off by maybe half a turn. And then we'll go ahead and tighten the lock nut. And we need to tighten the stinger in the collet. The last step in setting up the shaker is attaching the cable to the load cell. Now what we have demonstrated here is the proper setup of a